Can you guys hear me? Oh, now I see Sarah. Sarah, you're on twice. I see you and the strawberry.
My dad had me logged in upstairs.
Mela, I can't see your camera. Oh, now there's only one Sarah. And there's Claire. Hi, Claire. Denton Music Workshop. There's Finn. You can't hear us yet.
Is it okay if I turn in my stuff later today?
Yes, that's. Gonna go get some coffee. Hi, Karis. So how y'all liking being stuck at home?
I can't keep track of what day it is most of the time.
Yeah, because are you anybody able to actually go to church?
No, I've been in quarantine for like 3 weeks, and it's sad. We have like a tiny yard, and only thing in there is a trampoline with a rip.
There we go.
Yeah. So
There we go. I'm like Harvey Two-Face, just dark on this side. I don't know about y'all. I actually have enjoyed it. I've been just like you. I've been quarantined at the house since last Thursday. So this is day 8 for me, and I actually kind of like it. I've been working at home as much as I can, so it's a little bit different from my job. It doesn't work that well, but don't go out for church. Just go out and play in the yard sometimes. And went to Sam's on Monday, and that's the only place I've been beyond my own front yard and neighborhood. I like it. Because I'm an introvert. You probably didn't know that about me, did you? Kinda. It's like, how does an introvert talk so much? I always wonder that too. But if you put me in a room full of people I don't know, it's not my comfortable space. Howdy, Ben.
Hello.
How's quarantine?
Not that much different.
So have you been at home for like 3 weeks or 4 now?
Yeah, mostly.
I think for my kids, most of them haven't actually even left the house since the last time we met for science, which was the Thursday before spring break. Because they, well, actually, we probably went to church the Sunday after the first. Yeah, we did. We went to church the Sunday before spring break, and then they haven't been anywhere other than our house and the neighborhood since that day. So they're probably feeling a little bit more than me. I've been home for a week. So what was that, like the 12th? No. It was the 8th of March was the last time they even got to go out of the house to church. Actually, I think they might have gone somewhere on the 10th, something like that. But in any case, it's been like, what does that make it? 1, 2, 3, more than 3 weeks. All right, we'll give everybody a few more minutes to see if we can get everybody here. There's Davey. She probably can't hear us yet. Yep, there's Davey. Anybody doing like Zoom meetings and stuff for church or anything like that?
Not for church, but practically everything else.
I have a Zoom ballet class.
Zoom ballet class. It's a little awkward, right? It's sometimes it's easier to do things like that in a group, in the same room. We're all getting to learn some new skills here. I'm probably going to run over my internet quota this month just for Zoom meetings and whatever else. All my kids, or 3 of my kids, were on Zoom all at the same time last night doing meetings with their huddle groups at for our youth group at church, which that's really cool. Even as recently as say 2010, 10 years ago, none of this would have been possible. We would have just had to cancel the rest of our year for SIM. Streaming church services. I mean, I think YouTube started around 2010, so it didn't even exist 10 years ago or 12 years ago. Can you all hear my printer?
Yes, I can.
Is it really loud?
It sounds like somebody whacking something.
Yes, it is very loud printer. I'm not doing it. Somebody else in the other room is sending things to the printer. Yesterday I was in here working, concentrated on stuff, sitting here intensely staring at my desk or whatever. And the thing started going off. It started all of a sudden started, and I was like, whoa. It actually startled me a bit, which I don't scare easy. And that startled me. So who do we have now? Got Sterling.
Hi, Lily.
Lily. I see Michaela's joined, but I don't see Michaela. I just see a picture. And what is that? A cat?
Yeah,
Is your cat helping you with your homework?
my brother's cat. No, he's not.
Which brother?
Malachi.
Malachi's cat? Is Malachi putting the cat on the computer?
No.
Okay. Just seems like something he might do. So who are we missing? Sterling, stop doing that. Yawning.
Sterling, that's punishable by death. Stop.
Well, I don't know about death. Oh, there's Brady.
You can't stop me.
You can't stop you from yawning.
Or
Yeah, you could,
Yes.
we could give you some coffee.
I don't like coffee.
I literally just woke up like 4 minutes ago. I set
Don't you
my
like?
alarm for 7:40, but it never went off. I don't know why.
See, and when you get it to go to college, you're gonna love those 8 a.m. classes, especially when you've been up until 2 in the morning working on homework. That was a relatively normal occurrence for me in college. I don't necessarily recommend that approach, but it's certainly, it happens. And I didn't drink coffee when I was in college either.
big mistake.
I was, I don't know, it wasn't as trendy then, I guess.
Who
Not
here
that
actually, who drinks coffee that is in this meeting?
What's that?
Does anyone here actually drink coffee besides you?
I drink coffee.
Brady does.
Wow.
I drink coffee sometimes when my mom lets me.
Yeah, because every time you do, you're bouncing off the walls.
Not me. It takes about 3 or 4 cups before I start feeling jittery. Oh, I see we have Cedar joined.
Cedar, are you alive?
Yes, sir.
Ah, good.
Don't see you, Cedar. I just see a picture. You might need to enable your camera. I mean, unless you don't want us to see you.
Did that work?
Yeah, now I can see you. Maybe I should disable my camera.
We should make a Sim Science hangout. Like a Google group chat.
Use Signal. It's a good, secure app that we use for chatting.
Signal? I just figured everyone would have Gmail/Hangouts.
Well, yeah, we could use that too.
Or Skype.
I don't have
Then-
Skype.
Then we have to like randomly call every now and then. But if we had a chat, that way we could, 1, talk to friends other than just Thursday. 2, turn in our work more efficiently. I'm making a plan for this. We could turn in our work more efficiently by asking each other and the teacher questions if Mr. Sears was in the chat. And we could just communicate better, I guess. I guess we could time these meetings better
He's
also.
been planning this question for a week.
Yes.
Yeah, he's got his all presentation. Do you want to do your share your screen and put all your bullet points up here? No, I'm kidding. Actually, that's a really good idea, Finn. I can look into that. Now, obviously, security is a concern, so we want to probably find a solution that is going to be secure. But
Signal is really secure. It's what my dad recommends using for practically everything.
Signal.
Does anyone here actually have Signal besides Sarah?
No.
Yeah.
I don't actually know what it is. I'm getting to be one of those old guys who can't keep up with technology.
It's just a texting app.
Is it like GroupMe?
Similar. I mean, you text on it, but my dad finds it to be really secure, so.
I use GroupMe.
Well, GroupMe is more like an app for your mobile phone. So anybody who doesn't have a mobile phone, that may not be a possibility or a good tool. So we would need to find something.
I do have a mobile phone, but I share it with my 2 siblings, and they're teenagers. So you can imagine how much I really get to use that thing.
That happened to me all the time when I was like 12 or 13 or whenever I was little. So my mom got my brother a phone, a flip phone, okay? And then he grew out of that and we shared a phone, but it became his phone. But then I got a phone for Christmas. Thank goodness.
I still don't have my own phone.
We
Kids
all
with phones just
I have my
bewildered.
own phone, but I have like no storage space.
I
I
don't even
share-
have a share of a flip phone, guys. Get
I
real.
share an iPad with my sister.
Yeah.
Fun.
So it's just different for everybody. So it would probably be best to actually be some kind of an online program. Sarah, you were saying Signal, is that a mobile app or is that a website?
You can get it on the computer.
Yes.
It is a mobile app, but you can also have it on the computer.
Okay, so let me do a little bit of looking into that because, well, that's one thing. And Lily, your sister was in my class with the old. She was the last. Her class, or that year of her when she was in my class, was the last year we used a program called InGrade, and it actually had a chat function that you could use on all the different assignments. And we had one assignment that the students all got together and ended up doing this big old long group chat, ended up with over 2,000 comments. And I was able to moderate all of that, but we all had a lot of fun on there. And there were several, not science conversations that went on there. There's one, and you can ask Hope about this one, something about dogs versus horses. So not like dogs versus horses fighting, but dogs versus horses, who prefers dogs versus who prefers horses. So anyway, that was just one of the funny conversations, and I like that. That was something that was just fun and gave the students a chance to interact outside of class. So let's let me look into that, and I will see if I can get something set up in the next couple of days. So you can do that. All right. I think we're missing Sam yet, but I'm going to go ahead and get us started for our business of the day. And I will, well, let's just start with prayer, and then we'll dive in to a couple of housekeeping items, and then we'll jump into module 14. See what we can do here. All right, so pray with me. Lord God, we just come before you again today. We want to thank you for the opportunity we have to meet via technology in times that are challenging and unknown. And we all have various concerns and struggles and things that we're having to adapt to. And in addition to the fact that we're just uncertain about what's going on outside the walls of our home. And we're hoping, each one of us is hoping and praying that this virus doesn't affect our families and the people that we love. And we just pray that you would be with us through all of those things. Calm our fears, help us to trust and rely on you, and pray that you would keep us in your word, keep us grounded in your sovereignty, keep us safe, and if it be your will, I just pray that you would keep everybody healthy, and pray that no matter what happens, all of us would just keep trusting in you. Bless our time today here as we study science, and help us to grow and learn and give you all the glory. And we ask these things in Christ's name. Amen. All right. So, as I said, some housekeeping items I wanted to mention to you. First off, I sent out a revised syllabus last night pretty late, and I understand that you might have been surprised to see that I'm asking for experiment 14.1 today. And I want you to understand that all of this time, there's so many things and so many adaptations that we have to make over the next few weeks, that it's going to be all about let's figure this thing out together. So I am not going to be totally hardline about if you didn't get it done and charging late and all that kind of stuff. So we're going to try to be very flexible with you. All I ask is that you communicate. So if you can't get the experiment done, please let me know. And actually, if you have emails for our assistants, Mrs. Bauer, Mrs. Hedgelin, Cedar, how do I say your last name? Help me out here.
Hedgelin.
Hedgelin. Okay, thank you. I'll remember that now. Maybe. All right, so Mrs. Hedgelin and Mrs. Rowe. So if you don't have their emails, I would ask also that, if you've got homework questions, if you're asking for an extension, that you please send email to me, and you can copy all of our assistants from here out. Because if I, here's my side of the story. I'm trying to manage all the data. I'm trying to manage everything coming in and out. I get, every time one of you uploads a file to that Dropbox folder, I get an email, which is really kind of dumb on Dropbox's part. It says Dropbox is so-and-so has uploaded file, so-and-so has uploaded file. And literally last week when I saw my email, I had I had started with 20 unread emails, and the next time I looked at it, it showed 70. So it's kind of, if you send me an email, it can get lost in all that mess. I'm trying to stay on top of it, but I'm getting lots of stuff coming at me, so I might miss something. That's all I'm saying. No excuses. Not trying to give myself an out, but so let's. I will send you the emails for our assistants today, so you can copy them on any emails you send to questions about homework. Okay, y'all got that? Okay. And we're going to totally be flexible. We're not going to be, we're trying to just get through it. So I'm not going to punch you in the face for turning in a late assignment. Can't reach you anyway. Let's see. That was fist bump. So then experiment 14.1, if you can turn it in today, that'd be great. If you need till tomorrow, we can work with that. And I took some experiments off the list. You're more than welcome to do them. I'm not asking that you turn them in. Did I say something last week about doing some extra credit, counting extra credit if you do the other experiments that I took off?
I don't think you did. You just said that they're optional if you
Okay.
to just learn more about the module.
Right. And my intent was simply because I'm trying to make it to simplify things a little bit for both sides, for both the grading and for y'all. So if you don't do the experiment, you don't have to do the full report. You can do the experiment without doing the report, because I think that especially like you could do the one, the Doppler effect experiment, which is this month. It's 14.4, I think. And you can do the one about the speed of sound, which those were already going to be at home experiments. But I took them off just because I felt like they were going to be something that's going to, you kind of have to get out a little bit more. And that might've been hard for some people. So if you can do them, great. I'm not really planning on doing them for extra credit, simply because I'm trying to simplify both sides. We can consider that. You can ask me about it if you really want us to take a look at them or something like that. But at this point, I'm not planning to do that. What else do I need to tell you? I am working on your quarterly tests. I got a few of them graded, and it's going to be a little different. Since I'm looking at them on PDF, I'm not printing them all out and marking them up with a red pen. So I'm kind of figuring out how to do that. Basically, I've created a little grading sheet. So what you'll get is an email with a list of all the problems, all the question numbers and things like that. And it'll say whether you got it right, wrong, or partial credit. And it tells you how many points each point is worth, and so on and so forth. And it'll calculate the grade for you. And then I've got a little space for some comments. So if I had a mark or indicate why you got partial credit for something, usually it's on the partial ones that I've been putting the comments. So you'll just get a grade sheet that'll show all that stuff broken down. And I've been having to develop that. So another adaptation, but so that'll get, I'm not done with those, but I will probably be done with them by next Thursday. So those quarterly tests, and then you got the new syllabus. So you can kind of see, I took all the extra assignments off of it, all the pre-labs, I pulled them off of off the assignment sheet. I reworked it, and hopefully that works. So if you have any questions about it, let me know. All right. So does anybody have any questions or concerns with everything we've been doing this week, last week? Been able to figure it out? All right. Well, if you don't have any question, let's stop talking about weird stuff and talk about science. I'm going to switch over to slideshow. And let's talk about Module 14. Waves. It's easier to make dad jokes when you're not in front of a little camera.
You got to find a way somehow. We can't survive without your dad jokes.
You have
Yes,
to
we
figure
do.
it out.
We'll
You gotta
find a
figure
way.
it out, man.
Well, that was an effort at it. See, waves, and I'm making sound. All right. So, wave and sound. These this particular subject matter. Well, world would be weird without waves, and would be really weird without sound. So, if you want to know, just turn your headphones off or whatever and mute me. No, don't do that. Don't do that. All right. So, where do we start? Let's just talk about a few different types of waves. Places where you can see waves. And well, first off, let me just ask the question, what is a wave? Anybody?
Which
Bueller?
wave?
What'd you say?
Which wave?
What is a wave in general?
I think she means sound wave or like physical wave.
No, I mean like transverse wave or longitudinal wave.
Get longitudinal. Well, no, I'm not asking about either one of those. I'm more asking generally, what is a wave?
A type of movement.
A type of movement. Somebody said physical wave versus something. That was you? That was Finn, right?
Yes.
So what did you say, Finn? Say it again.
I said I was saying that I didn't know if she meant like physical wave or sound wave.
Oh,
I guess
well,
technically they're both physical.
they are actually both physical. A sound wave is it's just not visible. So you have other different kinds of waves, but a sound wave is just, it's still something physical, but it's just not visible. All right, so I've put up here a few different places where you can actually see waves. The probably most easily observable wave is the waves that you might see on water. Now you actually think about the little ripples that you might see on a lake or something like that as not necessarily waves, but that's simply because what you see on the water is a three-dimensional wave, and most of the time you think about a wave as being an up and down kind of thing, an oscillation. What a wave actually is, it's simply a mechanism of energy transfer where energy is traveling through from one area to another. So a sound wave is sound energy that travels through air or water, or it can actually travel through solid substances as well. But in water waves is just moving water. So somebody transfers energy to the water by, say, pushing on it or something like that, and you can create a wave that goes across it. Or if you drop something, a water droplet into a bucket of water, then it can actually create a ripple, and you can actually see those waves progress out in a circle. So water waves, while they're kind of, they kind of move up and down, it's just because it's a three-dimensional and it's waves coming from multiple sources. And so when they intersect at an angle, then it kind of creates those little peaks and valleys all over the place. So it's the mathematics of that is actually pretty complicated, but the principles are actually relatively simple. So all right, so you have, like I said, water waves. You have also electromagnetic waves, which we're going to actually talk more about that in the next module. Electromagnetic waves are oscillations in the electromagnetic field, and that's light, energy, and actually it's photons traveling through space. And it's just another form of energy, and it can travel around. Sound waves, sound energy that travels through air is when you can actually think about it like this. If you have a large plate or something like that, a big metal plate, and you push it back and forth, then it'll create a sound, maybe a little a low frequency sound back and forth. You could hear the waves, or you could feel the waves of air coming towards you if you did it like that, big old metal plate or something like that. Or you could think of like a speaker. If you ever see like a subwoofer and somebody's playing some Lecrae or some loud music like that, then you can actually see the speaker cone vibrating back and forth. And what's that's doing, it's pushing the air back and forth and back and forth, and it at a certain frequency. The faster it goes, the faster or the higher pitch the sound. And we'll talk about all those different little components, but that is just a means for you to think about or visualize a sound waves. So there you have it right there. What do waves do? They are a means of energy transfer. All right. So then let's break it down and talk about the different aspects or properties of a wave. Okay, first you have the wavelength. And as it says there, it's the distance between two crests of a wave. So if you have a wave, something like this, then the wavelength is the distance between one crest and the next crest. So the high point, the top point of the wave right here and there. Now it looks funny. It's like a cherry on top there. So these are the high points of the wave, up here and here, and the distance between them is the wavelength. And that is indicated by this little Greek letter we call lambda. And it looks like an upside down Y. Okay, the speed of a wave is simply how quickly the wave is traveling. So if you watch, let me think if I can actually come up with a, actually I can possibly, I have an app that might actually I don't think it'll work through Zoom. Oops. Okay, I'm not sure if I can actually do that. Okay, but if you were to actually, well, and let's think about it in terms of water. If you think, picture in your mind a wave traveling through the water. Somebody just joined. I just heard a noise.
I don't think anyone joined. We have the same amount of people. No, we have one less.
Yeah. We're waiting for Sam yet.
Someone got bored and left.
Oh, that's what it might have been. Might have been the exit sound. Okay, so
Take roll. Figure it out. Figure out who had done it.
All right, so if you picture a wave traveling through water, you can think, or you can probably imagine the speed of it. So say you drop, you put a drop of water into a calm pool, and then the rate at which the ripples progress away from that drop, travel out from the drop, is going to be, would be the speed of the wave. So as it's moving back and forth, that's the speed of the wave. It's kind of, you can't really draw it, but a wave, as it's transferring energy from one point to another, it just travels across whatever medium it is going through. So that really, I can't describe it better than that. Now, with the speed of sound, one of the things, or the principle of that is that sound is it travels at a fixed speed based on the temperature of the air. And it also, in solids, it travels at a fixed speed based on the material composition, and probably to a certain, maybe lesser extent, the temperature of the material or the water. If it's traveling through a liquid or water, then sound will travel at a fixed speed based on the temperature of the water. So that's an important principle of sound. But, say like a speed of a wave through water, it can actually vary based on how quickly or how much force is applied to it, or something like that. So for the most part, sound waves don't have a varying speed. All right, so then the last one is frequency, which is speed divided by wavelength. So you could write it this way: little f for frequency equals v is the lowercase v is the sign or the letter we use to indicate the speed of a wave, divided by this upside down y character called lambda. Boy, that red against the brown background is really harsh. I need to change that color. Blue. I don't have very many color choices. All right, and the frequency of a wave, here's how I understand or think about the frequency of a wave. The frequency is like a if you can imagine the your little brother, little son, a little boy, walking down the sidewalk in front of a picket fence, carrying a stick, and he's dragging his stick along the pickets, then the speed at which he's walking is going to determine the frequency of the stick hitting the fences. So if he's walking fast, the frequency is going to be da 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 da. If he's walking slow, it'll be da 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 da, and so on. Or you could also picture it as if you put a playing card or some card, a business card, in tape that to the fork of your bicycle, and then let the card hit the spokes. The faster you ride, the higher the frequency of the sound. So has anybody ever done that? Put a card in your bicycle spokes?
Well, I can't say I have.
Nor me.
Oh my goodness. You haven't lived. I remember doing that kind of stuff. We'd be riding our bikes around, and you wanted to have a motor on your bike. At least I did. So you'd put something in your spokes, so the faster you go, the more that makes that sound. And so you can feel like you have a motor on your bike. That was just the way I did things. Okay, any questions so far? Pretty easy. Actually, let me grab something real quick. I'll be right back.
Well, alrighty then.
Everyone spam the chat with useless information.
How did you do that?
I have my secrets.
That's amazing, bro.
Wow.
How long have you been a robot, Sterling?
Dude, I've seen ads for that app where it like changes your voice to be different for some game thing, but how'd you get it?
Voice mod?
Yeah. Is that on your phone or your computer?
Computer.
Bro, that's amazing.
That was actually creepy. I heard somebody sound like they were in a giant cavern or something like that.
I have a voice that's titled Cave.
Do it again.
There's ambient effects.
Okay.
Does it sound like I'm in the cave now?
That's so weird.
All right, so let's go back to talking about science for a minute. Okay, I have my little musical instrument here, and just wanted to kind of give you a quick bit about sound waves. Now, what I said before, sound waves are all going to be traveling at the same speed, depending on the temperature of the air. Well, all of these strings are exposed to the same air temperature. There's no variation in temperature between this string and that string. So the speed of the sound coming off of each one of these strings is going to be the same. But what is not going to be the same is the frequency. So if I pull the lower string, then you can actually hear the low frequency sound. And the high string, in contrast, is a higher frequency sound. And it depends on the guitar, it depends on the size of the string and the tension on the string and the length of the string. So all three of those factors determine what is the pitch that you hear, the sound that you hear. So this is low frequency, and this is higher frequency. And then, of course, you can play with the frets and change the frequency of the various strings to produce different notes and thereby produce music. So that's when we change the length of the string by pressing on the fret here, then you get a higher frequency. The short, because every time you do that, you basically make the string shorter. And that varies the frequency. So it actually, what it's doing, it's varying the frequency because I said the speed's the same. So it's varying the frequency by changing the wavelength. So each one of these produces a different wavelength, or each time I change each string produces a different wavelength. And then based on where I hold on the fret, it produces yet a different wavelength, and thereby changing the frequency. I don't think my guitar is in very great tune. Okay, so that's some very basic elements of frequency and sound. So I look like I'm jumping up and down. Okay, let's just keep moving. All right, let's looking at the frequency. This is the math part, so pay attention. Let's see if I can make this adequately clear. Remember, I told you the equation is frequency equals speed over wavelength. Let me try that again. There we go. That looks good. Now, think about this. Speed is going to be in a unit of, say, feet per second. And then this is the wavelength is going to be a unit of, somebody shout it out.
Time.
No, wavelength.
Hertz.
Say it again.
Hertz.
No, that's going to be this. That's the units of frequency. I'm just showing you how you get that unit. Okay, it's a unit of length. Wavelength, it's a unit of length. So it would be, say, in feet or meters or inches or miles. So you have feet per second divided by feet. So if you do the math, the units of feet cancels out, and you're left with units of 1 over seconds, which is a little bit confusing, but you could think about it as being a cycle per second, or cycle per second is probably as easy as anything. So that's your units, because the length units cancel out. That's why it says here the math cancels the length unit out. And so then you end up with a cycles per unit time. So 1 over seconds is the way it works out mathematically. And that's the unit of hertz, because it's easier to say hertz than it is to say 1 over seconds. And it was named for a gentleman named Heinrich Hertz, which we've actually learned about, or he's been mentioned before when we talked about the electromagnetic force. All right. And then the last property we have of a wave is the amplitude, which is like this. There's one wave. I know it's not very good, but and then I draw the center line through it. Then you might have another wave that has a higher amplitude and looks more like this. Well, that one is actually pretty good for drawing with a blunt object. So amplitude is going to be the measurement, the height of the wave. So measure from the axis to the top of the wave. And it would be in a unit of length as well for a transverse wave. For a longitudinal wave, it would actually be the diameter of the wave. So a longitudinal wave, which a sound is a longitudinal wave, and make sure you remember that. For a small sound, then the sound is going to be a small circle. And for a big sound, it would be a bigger circle. So that would actually be the indication of the amplitude of the sound on. Amplitude is a measure of the energy of a wave. So you think about going back to our water illustration, if you think about a little droplet, if we drop a grain of sand into a calm pool of water, then that calm pool of water is going to get little tiny sand grain size ripples, right? If we drop a rock, a small rock in there, then you're going to have ripples, small rock size ripples. If we drop a giant science teacher into the pool, then you're going to get science teacher size ripples. So who now wants to throw the science teacher in the pool?
I do.
Me.
I knew I'd have some takers on that. Yeah, good luck. You have to catch me first.
Deal. Challenge accepted.
I don't even know where you live.
We'll storm his house.
You guys do too know where I live.
I
At
don't.
least.
Well,
in
I know you
terms-
live in Crum, right?
I've been to your
Yes.
house, so I should know where you live.
Yep. Henry's gonna rat me out. Well, y'all come on. Come on, you well, after we're off quarantine at the end of the month. So
We're gonna take you down like the FBI.
well, first off, you gotta get me close to a pool of water. So, and there's not one here, and I'm not sure where there is one close by.
We'll just have a pool party. Nobody can resist coming to a pool party.
Yeah, there you go. So somebody's gonna set up a physical science pool party the end of the year.
Sterling's
Sounds-
house.
Of course, Cedar's gotta be the one to tell everyone about my pool.
Most of us have been to your house, remember, Sterling?
Yeah, but not Mr. Sears.
You still can't get me in the pool unless I let you. I'm just saying. Now, I actually happen to really like swimming, so I might actually cave.
14 against 1. I mean, I know we're kids, but
How many push-ups do you do in a day? All right. Well, just for the record, I did 220 yesterday. So it ain't bragging if it's true, right?
Oh, it's totally bragging.
if it's not
Yeah.
true, you shouldn't brag about it.
Local
That's true, 'cause
sign
that-
on
Oh,
the
look at this.
newspaper. Local science teacher flexes his athleticism on his kids.
All right. Just a sec.
don't tell me this is this X and Y axis that I have been worried about.
The X and Y axis.
Yes, I see the Y and the X up there, and I see paper with squares all over it.
Yeah, this is graphing.
Did we get what back yet?
Oh, can everybody see that? Yeah, Finn,
Yeah.
can you
Yeah,
can
yeah,
you
I was
hear us,
pretty
Finn?
confused about that.
No, I can't hear you, Finn. Hey,
It says that he's mute. Wait, no, it doesn't say he's mute. Maybe his mic has a separate mute function, because that's just what I use. I don't mute myself through Zoom.
yeah, that message was just for Finn. He said his audio stopped working, so I didn't realize I was sending it back to everybody. I could see that it says send to everyone.
There's when you're typing a message, right above type message here, it says
Yeah.
to blah blah blah. You can send it to whoever.
Yeah.
At some point, we should all have a typing competition. Who can type the alphabet the fastest?
Well, you know
At
what?
some point, we should all storm Henry's house and shame him for trying to get us to do a typing competition.
Guys, I'm on
Good
a
idea.
phone. I can't type on a phone.
Yeah, some people aren't on computers.
Yeah, with the G's Gomet, Henry.
Well, I don't know. It sounds like Sterling's trying to get out of it.
I will
You
be
want to
back.
see my keyboard?
Sure.
Okay. Well, Finn, I don't know if you can hear us at all. I hope you can. But we're just going to keep going best we can. And if you get back in, okay.
Chair is so
Finn
sweet.
can hear me, but he's on permanent mute, and I didn't do it. He's going to reset, so he'll jump out and then jump back in. All right. Okay, so let's keep on talking. This is transverse wave. Yes, this is a graphing function. So if you're doing algebra 1, you get to actually learn about the Cartesian coordinate system, and that's what this is. So you have your x-axis. You have your x-axis like this, and your y-axis like this. So the vertical is the y, the horizontal is the x, and this is a trigonometric function called sine, which is actually a ratio. That's a ratio of a right triangle. It's the ratio of the length of the opposite side relative to your angle divided by the hypotenuse. So don't worry about that. Just know that this is a way to come up with a representation of a wave function. So but this is your basic. This is a basic wave pattern. And of course, we can do different things to it to actually vary the properties of it. You can add a number in front of the sine function, multiply it by 2, and then it will actually come up to here and down to here. So that would double the amplitude of it. Or we could actually put the 2 on the x, and it will actually make it would that make it go like this and then back down? And it would double the wavelength. So you can change those functions, but this just changes the frequency of the wave. And the sine is a means of measuring a sine wave. That's what they call it. And it's actually, the function is this, S-I-N-E. So it looks like it says sin, but that's just an abbreviation, mathematical abbreviation. So here, tell me what is this property of wave. Here's a little quiz for you.
Wavelength.
That is the wavelength. So there's your lambda. And then, of course, we can't really see what the frequency of the wave is because this is a still picture. So we can't tell this frequency of the wave. What will we need to find the frequency of the wave?
The amount of waves that hit a certain spot each second.
Or yeah, that is the frequency of it, but
Mathematical formula.
what other part, what am I missing to be able to determine the frequency of the wave?
The speed and the wavelength.
I've got the wavelength, and so I would need to know what is the speed of the wave. We don't have that because, like I said, it's a still picture. And then the last quiz question, what is this?
Amplitude.
That is the amplitude. Sometimes we indicate it with a little a. So there's your basic breakdown of a wave. Simple. Don't worry about the sine function stuff. We won't have any questions about that on a test yet. But when you get to go to trigonometry, then you can. Okay, so that's your transverse wave. And here's the definition. These are my favorites, a couple of my favorite vocabulary definitions for this whole entire book. Finn, if you're trying to talk to me, I can't hear you. Can you hear us? And then since you went out and logged back in, then it's probably not an issue with the program. It's probably your microphone is turned off.
Yeah, there's probably a separate mute function somewhere that you turned on.
Okay.
Or maybe his headset isn't plugged in all the way into the computer.
Yeah, check your headset connection. You can there might be a button on the little microphone that's connected to the earpiece, whichever one that is, and you might have pressed that button that mutes it. I'm not sure. I'm just guessing. So somewhere there's a setting, or it could be that your microphone on your earphones completely failed. So I don't know what else you can do about it. Okay, so let's talk for a minute about transverse waves. And unfortunately, I can't ask you the definition because I've already got it right there. A transverse wave is a wave that's the direction of propagation perpendicular to its direction of oscillation. Now, what in the world do all those words mean? Well, propagation means the direction the wave is traveling. So your wave may be traveling like this, so its direction of propagation is going to be this way. So that's the direction of propagation. Now, with your normal sine wave pattern, then the direction of oscillation is like this. It's up and down. And you notice that the oscillation is going at 90 degrees to the direction the wave is traveling. So that's what it means. Oscillation, the word oscillation is it means back and, back up. That didn't work. Oh, don't do that. There we go. Back and forth. So you might actually have, or if you don't, you've probably seen, maybe at your grandma's house, an oscillating fan. An oscillating fan is one that simply has a head that will turn back and forth. It oscillates, so it's basically going between two limits that's controlled by a little arm inside the fan that is on a rotating shaft that moves the arm back and forth. So it oscillates back and forth. Or your windshield wipers. Your windshield wipers oscillate. They go across and then back and forth, back and forth. So there's two different examples of oscillations. So just so you know what that word means. Or it could be like up and down. So your pedals on your bicycle oscillate. They go up and then down. Especially if you look at them from the front, it looks like it up and down. It's actually going forward and back as well. So those are some examples of oscillations. Okay, a longitudinal wave. Longitudinal waves, direction of propagation is parallel to the oscillation. And there's a picture in the book that's going to be better than what I can draw. But basically you have the wave is made up of compressions and rarefactions. So it looks like something like this, and then it'll have a whole bunch of lines stacked up. Oh, this is terrible. This is just not working at all. That looks like a 3-year-old scribbling. There we go, fixed it. So actually, I have here, somewhere amongst my belongings, I have a Slinky. I believe I know where it is. Ta-da! And I can actually show you this, and it'll probably make a really terrible sound on the microphone. So I may have to mute myself, or you might want to turn your speakers down. So let's see if I can get this in my camera view on my table here. And I have a whole pile of wires and glasses and other stuff that I got to get out of my way. All right, let's try this. Switch cameras. There you see, you can see the ugly mess I've got on my desk. Oh look, I got the little silica gel thing. I don't even know why that's in there. It's always been in my little Slinky box. But I can actually make a wave, and I'm not even sure how well that'll actually come across on your screen. So you might grab a Slinky that you've got at your house, because if you're a homeschool student and you don't have a Slinky, that would be astonishing.
I've got a metal Slinky.
Yeah, that's what this one is. It's actually like, you get them at Cracker Barrel. I believe that's where I picked this one up, and expressly for SimScience many years ago. But you can kind of see, hopefully you can see, as I compress the wave, as I create the wave on the one side, I'm going to do it from my right-hand side. And then you can see it actually goes across and comes back. So there, that's kind of what a longitudinal wave looks like. Let me do a whole bunch of them here.
Is it working now?
That
I think
is
I got it.
probably not coming through.
It comes through okay, but Finn's back.
Finn's back?
Yeah.
You figured it out?
Yeah, I figured it out.
I'm pretty sure he did because my computer only has it to where it only shows people that are talking or making noise, and showed him for a little bit.
Can you hear me right now, Sterling?
Mr. Sears is secretly going to be playing with the Slinky the whole time while he's teaching now.
I don't have
We
a
just have it out of view.
Hey, what?
If
I
you don't
don't
have a
get a-
slinky, if you don't have a slinky, you can't understand waves.
I don't have a slinky either.
Well,
Yeah, but if you don't have one, you will never understand waves.
I used to have a good one, but then it broke.
Yeah,
what
they do
little,
that.
My siblings broke all of mine.
I was gonna say, if you have little brothers, they can break things with a surprising quickness or rapidity or frequency. There we go. Let's just
Metal
use
ones are harder to break. They're a little better.
Yeah, I have a metal one. Oh, they're really easy, and I don't let my 4-year-olds play with them with this one, actually, or anybody really. I keep it because I want it for this class, for this one lesson. And you can see the longitudinal wave going this way. But video compression probably ruins that to a certain extent. But you should try that. You should get a Slinky and then stretch it out. You know, the farther you stretch it out, the more satisfying it is to actually create those waves. And you can see it actually travel along the Slinky, the compression of the coils, and then it travels along the Slinky. And that's that's your example of a longitudinal wave. So the oscillation of a longitudinal wave is where the sounds or whatever, they become, the compressions get closer together. The coils of the wave get close together and then far apart. And so if you were to actually watch it in a single frame, it would do something like this. If you were trying to follow along that, it would do something just kind of a compress and then open up and then compress. So that's your longitudinal wave. Those are actually a lot harder to picture, but sound waves are longitudinal waves. And like I said, if you can picture sound waves like a Slinky attached to a speaker, then as that speaker vibrates back and forth, then those compressions actually progress out, they propagate out from the speaker into the air. And then they eventually make it into your ears, which actually that's another, your ear, study of the ear, discussion of the ear is another very fascinating aspect of understanding sound. Understanding the sound waves and stuff like that. Your ears are actually specifically designed to capture sound and funnel it into your ear channel in such a fashion as you can actually tell with your 2 ears, you can actually tell where the sound comes from. So you hear something behind you, you can turn and you heard where it came from. And if you actually, I was watching, there's a YouTube channel he's a pretty good one called Smarter Every Day. And you can actually get on there, and he has some stuff where this guy took his son and he stuffed like wax in his ears and changed up the shape of the ears and made it so he couldn't tell where the sounds were coming from. And which just demonstrates that your ears are designed to capture and you can actually tell where the sound is coming from no matter where it is, if it's above or below you, if it's behind you or in front, if it's to the right or the left, based on the design and the shape of your ears, which is pretty fascinating. That's not really related to the subject. That's just a little bonus material for you, but you can actually look that up under Smarter Every Day. They did a test where he had his ears just normal, and he was blindfolded. They'd go close or somewhere around him and just clap softly, and he would turn and point where was the sound coming from. He could always get it right when he's blindfolded, until they messed with his ears and put Play-Doh or something in his ear and changed the shape of them, and he couldn't ever get it right anymore. So fascinating stuff. All right. Speed of sound. Now, this is experiment 14.2. If you have a chance to do it, I would recommend doing it just because it's a very interesting experiment. It's hard to get it very accurate, so you have to be pretty pretty careful in how you do it. Control the variables, just like every other experiment. We try to control the variables. The better you do it, the better you control them, the better success you're going to have with your experiment. But you could get it pretty close. All right. The sound speed depends on the medium through which it's traveling. In gases like air, the sound is going to travel its slowest. It's not slow by any stretch of the imagination. It travels faster in liquids, and then obviously fastest in solids. And that's simply because in gases, your molecules, energy has to transfer from one air molecule to the next. In that energy, the molecules are more spaced out in gases. In liquids, they're closer together. And then in solids, all of your molecules are packed as tightly together as they possibly can be. So, that should be pretty obvious. Now, I think your book had a table of different materials and the approximate speed.
Page 351.
351. So in air, it's 340 meters per second. If you don't think in meters per second, that's somewhere in the range of I want to say like 1,200 miles per hour, 1,100 miles per hour. So it's not slow. Or is it 700 miles per hour? I think it's actually somewhere in the range of 700 miles per hour. That's right. It's like 12 or 1,300 feet per second, which works out to be 750 miles per hour. Let me see if Siri can help us with that. What is 346 meters per second in miles per hour? It didn't do it. (773) 774 miles per hour is 346 meters per second. So that's why it takes a supersonic jet traveling at extremely high speed to break the sound barrier. In alcohol, it travels at 1,186 meters per second. So that's 3 times faster, almost 4 times faster than it travels in air. Fresh water, 1,435 meters per second. So not too far off of 5 times faster. It's like 4.5 times faster. And then in wood, 3,800 meters per second, steel 5,000, aluminum 5,100, iron, and then glass travels fastest at 5,500 meters per second. That's 5,500 meters is like 3 miles per second. So yeah, that's pretty quick. I can run maybe about half that fast. Okay. All right, and as I've already said it, but it's right there on the list. Sound speed in air depends on the temperature. And I have one more little thing to show you here. I'll be right back.
Guys, is my mic working again? Is it working? Can you hear me?
I can hear you a little bit.
How so? A little bit.
Hey, there's Finn again.
You are very quiet.
Make me louder. Cedar.
He's drawing on his screen. Oh, my word.
Cedar, you are under arrest for drawing on the screen.
Wow, that was really loud. Okay, anybody know what this device I've got here? Let's see.
Walkie-talkie or radio?
Nope. It's in mirror image.
It looks like a stud finder thing.
It does kind of, doesn't it?
Ghost
got a couple of-
detector machine.
Couple of little level vials for checking to make sure you're level. It's a pretty
a
cool little
pressure
device.
detector?
If I turn it on, look at the screen when I turn it on. Tell me what it says. Oh, you totally can't read that.
It says green. Is that 7.15? 7.16?
It says it's backwards for you, so it's kind of hard to read.
It's not backwards. It just looks that way because
71F.
Yes, it says 71F. It says backwards to me. Maybe it's not backwards to you.
Yeah, no. I can read the Craftsman and the Power. It's not backwards.
Okay, so it says 71, and then there's a little degree symbol there. So it's taking the temperature. This device has a little thermometer in it. So any idea what it is?
A temperature detector.
No, it's not. It's actually a ruler. It's an ultrasonic ruler. So they actually, I have another ruler that's not ultrasonic, and I have let me show you that one. It's right.
From now on, we're gonna call Mr. Sears Inspector Gadget.
Yeah, this is another one here. It's also a little Craftsman. This one doesn't actually take the temperature. This one's a laser ruler or laser measuring device. So it actually has a little laser in it. Ah, I'm reflecting it right in my own eye.
Point
Well, that's kind of
point it right back at the camera.
That's a kind of
Yeah.
a cool effect. I kind of like that. I'm gonna look like I'm exploding. So this one is a laser measure. This one actually is an ultrasonic, so I can actually, I can turn this on. It takes a temperature measurement, and then if I point it at the wall or something over there, then it makes a little clicking sound, which you probably can't hear. Let's see if you can hear it. Can you hear the little clicking sound it's making?
Yeah.
Yes.
Okay, what that is, it's sending a little sound pulse out, and it has to take the temperature of the air, so it actually knows to measure, it knows what the actual velocity of sound is, what the speed of sound is at that given temperature, so it can actually calibrate its calculation. And then it listens, it's got a sound emitter here, that's this little, the big space here. It's got a sound emitter with a sensor inside of it. This is just actually this little piece is a laser to make sure you're pointing it at the right place. And I think the battery is too dead. Nope, it does a little laser. Oh, that's kind of cool. I can actually hear the sound feeding back through the device. So anyway, what it's doing is it'll calculate your distance based on, so it's now putting up a units in feet, and it's just really hard to get it to a point where you can actually see the reading. But so it says like 2 foot 8 inches, which is not correct at the moment for what it's measuring. But the point is that it actually calibrates based on the temperature of the air, so it knows what the airspeed is, and then it measures how much time it takes for the sound to travel across the room, bounce off the wall, and then come back to the device. And then it calculates the distance based on that time. So it's using it's actually calculating using the formula that we learned in module 9, that is speed equals distance over time. And what it does is it takes a time measurement and then rearranges the formula to, it's like this. It's actually time. Oh, sorry. Time, not time. It's solving speed equals distance divided by time, and distance equals speed times time. Just doing a little algebra there. So you multiply both sides of the equation by t for, and then that cancels out the t on this side, and distance equals speed times the time. So it calculates the speed and then multiplies that by the time that it takes for the sound to go over there and bounce back, and then divides that in half, and it gives me a distance measurement. So that's a pretty nifty little trick. And I think that's all the time we have for today.
Yeah, there's like 5 minutes left.
Is my mic working better now?
Yep.
Yeah, but we're almost done, so.
I know, it was perfect timing.
Yeah. I didn't do that.
Some of the best timing I've ever seen.
So,
Yeah, we're
anybody have
usually.
any questions or any thoughts or something you want to share?
Well, I was hacked by a space gerbil, so.
A space gerbil?
Finn, I can see Finn talking, but I can't hear what he's saying.
How?
Go Broncos.
Sterling, listen to me. Listen, Sterling, can you hear me? Sterling, say something.
I can
Oh,
hear you.
Finn, it's
Something.
I can't hear Finn. I can see him shaking his computer,
we
but
can hear Finn.
Raise your hand if you can hear me.
I
can you
hear
hear
you,
us?
Finn. I can hear you loud.
I
and
feel like I
clear.
have so much control since I got
Oh,
everyone
you
to raise
can.
their
Don't
hand,
mess
but
with
I guess
him.
that's really worthless. I should go cry now.
Can you hear me, Finn?
Yeah, I can.
Good.
What's up? Don't ask.
Finn is in agony.
I
You
love that
are-
voice changer.
Are you auto-tuning yourself now?
He has a voice changer called Voice Mod.
No, this is what I sound like normally.
Oh, I get it. He just
The
always
rare
says
condition. I
auto-tune.
really wish you wouldn't make fun of it.
I think you need to sing Amazing Grace for us.
Yes.
You can't use steroids to win the Olympics, but you can auto-tune to win a Grammy.
What?
That was
I only
good.
heard
It makes sense.
Grammy.
He says you can't use steroids to win the Olympics, but you can use auto-tune to win a Grammy.
Yeah,
That makes sense.
that's telling. So does anybody else play a musical instrument since we're talking about sounds and wave?
I played the
but-
I played a little bit of
I
piano.
want to learn how to play the harmonica.
My brother
I have a harmonica.
plays drums and my other one plays guitar. I am not interested in playing an instrument though.
I play drums.
I play piano and I'm working on playing drums.
I
I play video games.
ukulele.
There's one reason I want to learn how to play the harmonica.
Why?
So I could play Piano Man by Billy Joel.
Dun dun dun! It's Billy Joel, mate.
I don't know what it's
Piano
I
Man.
understood that
Finn,
reference.
I heard you. Finn,
What?
you spoke. And
We
we
can
heard.
hear Finn now. Yay!
I've
could
been
hear
able
him
to hear
before.
Finn for the
Mila
past
fell
like
off
5
the camera.
minutes.
Also, Brady understood my reference, which Brady, I gotta give you credit for that. That was a tough reference. And almost everything I say is a reference. You understood that. Good job.
Jim Gaffigan.
Yes.
I got that reference. I didn't.
Billy Joel.
I didn't even hear it.
I couldn't hear the reference.
The reference was Billy Joel.
I know who Jim
Joel.
Gaffigan is, but I did not get the reference.
That's just sad.
He was recently in a movie.
You are under
actually.
arrest.
Jim Gaffigan was in a movie.
He was in a movie. He was in a movie
Route
about
Zero.
people.
I did not like that movie. It was a bad movie. It was
Sacrilegious.
Is the meeting gonna shut off in 1 minute?
It shuts off when I end it.
Don't end it.
I have the power.
We have
Horsepower.
after class conversations. That's technically legal.
We have what?
After class conversations on a normal basis.
That's what my math teacher does. She leaves it open for us to have a conversation, but I never do.
Horsepower is completely different from girl power.
I got that reference.
That was weird.
You go, horse. Hey. Is what horses eat.
What was that sound?
That was probably
Sound.
Sterling.
You guys are so cute.
Yep, that was
Oh
Sterling.
my gosh.
How do you-
Sterling is using the baby filter on voice mod.
How do you guys change the
baby filter.
background of your screen?
You dab.
You have to find a
It didn't
picture.
work.
You have to find a picture on
Didn't
Google
work.
and then like upload it into Zoom.
I can see Henry's dad in the background. And he says,
Hello there.
I didn't know if that was Brady or Sterling's sound effects.
Sterling, do the
I
do
don't
the
make
Titan.
sound effects.
Sterling, do the Titan sound effect.
No, Brady. You
Yes, it's perfect.
Brady often says hello there. So I didn't know
Hello
if it was
there.
Brady or Sterling.
I actually have the hello there sound effect on here.
do it.
'Cause you
do
can
it.
have sound effects as well as voice changers on here.
Hello there.
I usually play this every time I join a Zoom call.
General Kenobi.
You are a bold one.
You guys are just geeking out. Okay, wait. I have an election to take. Okay, who here thinks
Election?
that the first three
I vote
movies
me.
were better than the last three? Raise your hand if you think the first three were better than the last three.
Of
First
what?
three what?
Star Wars. That's
First
the topic.
Way better. First three was way better.
Agreed.
What's Star
First-
Wars?
Wait, are we talking about the prequels by
Yeah,
first movies?
the prequels or the Kylo Ren Rey thing.
Well, sequel trilogy
that
is
can-
terrible, so
Amen.
No,
The
Force
love them.
Awakens was pretty good, but they ruined everything with Last Jedi.
Yeah, The Force Awakens was the only good one in the mix, and then the other two were just kind of like, wow, I can't believe you've done this to Star Wars.
Guys, look at my cat. She's
it's
so
an adorable cat.
Wait,
There she is. I remember
Cedar,
her. She came
Cedar,
to
get-
visit me at like 3 a.m.
that's creepy. Cedar, get the
Remember,
fat
I was
one. Get
was
the
having
gray
a
one.
Finn, remember when we all hung out at Cedar's house?
Yeah. She came over and sniffed you.
Yeah, because you couldn't stay for the sleepover, but I
Yeah.
did.
Oh, Leia. Her name is Leia, by the way. She's trying to escape.
It's Gimli. Say hi, Gimli.
Hey.
Gimli.
Cats are better than
Gimli.
Oh my god, Brady's dog is cute.
All right,
Gimli. Bye, Gimli.
Alright, I'm gonna let Leia go, too.
The
Bye-bye.
little wiener dog.
We
All
call
right, I
Leia-
reckon it's time for us to boot out of here and let the next class jump in. So just a quick reminder, the syllabus that I sent out yesterday, the work schedule I sent out at the very last column on the far right-hand side of the document shows the work that's due each week. I do try to get an email sent out. Sometimes I'm pretty late getting it out, like this last week. Everything has been a little bit hectic. For obvious reasons, I'm trying to work from home and things like that. So it's been interfering with my schedule, plus just everything I'm trying to adapt. So just like y'all, and like I said, I'm gonna be showing, or we'll be giving some flexibility. And I just ask y'all give us a little bit of flexibility as well. We're going to get through, and my hope is that we at least get to have our year-end party, or we might get to meet in May. But in any case, y'all just keep letting me know. I'll look for a program so we can actually have a little online forum and whatnot, so we can communicate with each other and whatnot. For the rest of this month, because we're definitely not going to be meeting until until May at the very soonest. There's just the governor has issued an edict, so we're not going to be able to meet until then. So we'll set that up. I'll try to get that set up, and y'all just let me know if you have any questions. You can call me, text me. Texting me is probably the best way, because I see that. If you email me, sometimes I miss them just because they get lost in the sea of other emails. And it's not intentional by any stretch, but I've found myself a number of times seeing things 2 or 3 days late. All right. So y'all have a good weekend, and I will see you again next Thursday.
Bye, amigos, amigo.
Oh yeah, Finn, you never answered my question.
What question?
Your question?
How does Harry Potter get down a hill?
I don't know. I didn't watch Harry Potter.
No, how does he get down a hill though? Just think about it.
Parkour.
No.
I don't
How does he
know.
get down a hill?
He walks.
You guys are supposed to is rolling.
See ya.